Welcome to the deep dive. Today, we're going deep on turbidity measurement. We've got a whole pile of tech specs and manuals here, so get ready. We're going to figure out how this technology, keeps our drinking water safe
Yeah.
and helps industries run smoothly, and even tells you if that swimming hole is, a little too murky for a dip.
It's amazing what we can learn just by shining a light through water.
Okay, so we're talking about making the invisible visible, right? Like we have this Turbimax CUS52D sensor. It's like the Sherlock Holmes of water quality, using, this light scattering thing to solve the mystery. But honestly, I'm kind of picturing a laser show in a glass of water. Help me understand how this actually works.
Well, imagine like a beam of light shooting through some water. Any particles in the water will scatter that light. And the CUS52D measures that scattering. So more scattering equals higher turbidity. Basically, how cloudy the water is.
So if I'm getting this right, like a clear mountain stream would have very little scattering, while a muddy river after a rainstorm would have a ton, right? But why does this sensor use light with a wavelength of 860 nanometers? Is that just like a science thing?
It's not just a random science thing. It's strategic. That wavelength is like a finely tuned radar, perfect for detecting those tiny particles that can make drinking water, unsafe. We're talking stuff you can't even see, but this sensor picks them up, like instantly.
That's incredible. But most of us aren't, testing our drinking water every day. So where else does this tech come in?
Oh, the applications are huge. Think about industries that use water for manufacturing. They need to monitor the water quality all the time. Or water treatment plants, making sure your tap water is safe. This sensor even plays a role in, filter performance, making sure they're actually doing their job.
Wow, this is way more widespread than I thought. But how do we know this sensor is giving us good information? What's stopping it from just spitting out a bunch of bogus numbers?
That's where the solid state reference comes in. It's like every sensor has its own fact checker. Making sure the readings are accurate. When they're calibrating the sensor, it gets married to its reference. It's a match made in accuracy heaven.
Okay, that makes me feel better about, trusting the data. But it seems like the CS52D can do more than just turbidity. I saw something in the manuals about it measuring other stuff too, right?
It measures temperature and solids content too. Temperature is important because it can, mess with the turbidity readings. And knowing how much solid stuff is in the water, like kaolin or diatomite, gives us a better picture of what's in the water.
So it's like a mini lab all in one device. But hold on, wouldn't where you put the sensor affect the readings? You wouldn't just throw it in a pipe anywhere, right?
Placement is super important. The manuals are really specific about where it goes in the pipes. Think about it, flow direction, air bubbles, even the angle of the sensor. All those things can mess with how it works. It's all about finding that sweet spot for, getting the best data.
So we've got our sensor, perfectly placed, sending out tons of data. But who or what makes sense of all those numbers? It's not just a person with a calculator, right?
Nope. That's where the Liquiline CM44X transmitter comes in. It's the brains of the whole operation. It takes those raw numbers from the sensor and, turns them into something we can actually understand. Think of it as like mission control for your turbidity measurements.
So it's like the sensor is sending out a code and the transmitter decodes it. But how do we know the sensor is even working? Does it send out an SOS if it breaks?
Actually, the transmitter has something called heartbeat diagnostics. It keeps an eye on the sensor's health and lets, if everything's running okay or if something needs attention.
Heartbeat diagnostics. That's a cool name. So the sensor's sending out a little pulse, hey, I'm good, or uh-oh, something's wrong.
Exactly. It's a good way to think about this complex system that's always making sure the sensor's working its best. But what happens if you're in a situation where the sensor gets, gunk on it? Like trying to read through a layer of grime. That'd mess things up, right?
That's a good point. What do you do then? Do you have to clean it all the time yourself? That sounds annoying.
Not at all. For those messy situations, there's this CYR52 ultrasonic cleaning system. It uses high-frequency sound waves to blast away any grime. It's like a tiny power washer for the sensor, keeping it clean and the readings accurate, and you don't have to do a thing.
Whoa, sound waves to clean a sensor? That's high tech. But before we get too deep into ultrasonic cleaning, let's back up a bit. We've covered a lot, from lasers in water to sensor placement and even this cool cleaning system. What else is there in this turbidity world? I'm ready for more.
Yeah, we've covered quite a bit. But there's more. Remember those flow assemblies we talked about? They're super important for making sure the sensor's got a good environment to work in.
Oh, yeah, the manuals mentioned those, but I kind of skinned over that part. Why are they so important? They just sound like, plumbing stuff.
It's more than just plumbing. These special assemblies, like the CUA252 and CUA262, are all about integrating everything smoothly and keeping things like perfect for the sensor. They make sure the liquid flows nice and steady, prevent any gunk from building up and messing with the readings, and some even clean themselves. Low maintenance, right?
So they're like giving the sensor a spa treatment, keeping everything flowing and clean. It sounds like they do a lot of work behind the scenes to keep things accurate.
Exactly. They're the unsung heroes of turbidity measurement. And speaking of heroes, we can't forget about the Liquiline CM44X transmitter. Our mission control.
Right. We talked about how it decodes the sensor's messages, but what else makes this transmitter so special? The manuals mention some serious flexibility. What does that even mean here?
It means you can customize this system to do exactly what you need. You can choose to have like 2, 4, or even 8 channels. So you can monitor multiple things at the same time, all in one place.
So it's like having a whole team of sensors working together, each giving you a piece of the puzzle. That's pretty cool. But with all this fancy technology, it makes me think about safety. What about places where things could, explode? Are these sensors a fire hazard?
That's a really important thing to think about, especially in like factories and stuff. Don't worry, these systems are designed to be safe. They have features like explosion protection so the sensor can't start a fire. And those diagnostics we talked about, they help with safety too. They tell you how the sensor's doing so you can fix any problems before they become dangerous.
Okay, so they built safely right into the system. That's good to know. But these days, it's not just about collecting data, it's about what you do with it. How does turbidity measurement fit into like the bigger picture of data management and control?
That's where connectivity comes in. The Liquiline transmitter isn't just a standalone thing. It can connect directly into your control systems. Imagine getting real-time insights, seeing trends, and making decisions based on what the sensor's telling you.
So you're talking about taking that raw data and turning it into like usable information. That's wild. This whole deep dive has really opened my eyes to how complex and important turbidity measurement is. It's not just about, is the water clear or not? It's about public health, industrial efficiency, the whole thing. But with all this talk about accuracy and precision, I gotta ask, are there any limits to this technology? What happens if the water is like super turbid?
That's a great question. Like any technology, these sensors have their limits. One of the big ones is the measuring range. The Turbimax CUS52D, for example, can accurately measure turbidity up to 4,000 FNU.
FNU. What's that stand for again? It sounds like something out of Star Wars.
It stands for Formazan Nephelometric Units. Think of it like using teaspoons to measure flour. It's just a standard unit that everyone uses, in this case, for turbidity.
Gotcha, that makes sense. So if the turbidity is higher than 4,000 FNU, the sensor can't really give us a good reading, right? What happens then?
Right, if it's too high, the readings won't be accurate. That's why it's super important to choose a sensor that can handle the levels you're dealing with. Sometimes you might need a totally different type of sensor for really high turbidity.
So it's like using the right measuring cup for baking. You wouldn't try to measure gallons of water with a tiny cup. You need the right tool for the job. What about interference, though? Could things like chemicals or temperature changes mess with the readings?
Absolutely. Interference is a big deal in turbidity measurement. The manuals talk a lot about understanding what could cause interference. Like even something simple like air bubbles dissolved in the water can scatter light and make it look more turbid than it really is.
That's crazy. So it's not just the particles themselves, it's about everything that's going on in the water sample.
Exactly. It's a whole bunch of factors interacting with each other. That's why cleaning and maintenance are so important. If you keep the sensor clean and calibrated, you reduce the risk of interference and make sure your readings are accurate.
So it's like a team effort between, human know-how and this high-tech equipment. We need to understand the limits and take good care of the stuff to get the most out of it. This has been a wild ride so far. We've gone from lasers and water to flow assemblies and even invisible air bubbles messing things up. It's kind of wild to think how much we depend on this, turbidity measurement stuff without even realizing it. It's like working behind the scenes, making sure our water is good and our products are like high quality.
Yeah, you don't always see it, but turbidity measurement is super important for public health, industry, even the environment.
Speaking of the environment, it makes me think about all the like rivers and lakes and oceans. Turbidity's got to be a big deal for, keeping those ecosystems healthy.
Oh, absolutely. Turbidity is a major indicator of water quality. Like if the water's too cloudy, sunlight can't get through, which is bad for the plants and animals that live there. Too much turbidity can also mean more pollutants and less oxygen, which makes it hard for fish and other creatures to survive.
So it's not just about whether the water looks nice. Cloudy water can really mess things up.
Right. By tracking turbidity, we get a better understanding of how healthy the water is. We can see where the pollution is coming from and how human activities and natural events are impacting things. And with, climate change being such a big deal these days, Understanding turbidity patterns can even help us predict and deal with, like, water shortages and stuff.
It's crazy how something as simple as, cloudy water can tell us so much about the environment. It really shows how connected everything is.
Yeah, it does, and it really highlights how important it is to keep, researching and developing these technologies.
This deep dive has been awesome. We started with lasers and a glass of water, and now we're talking about like all this complex stuff, sensor placement, cleaning systems, data, the environment, the whole thing.
It's been a really interesting journey. Hopefully you've got a new appreciation for this technology that's often overlooked, but, it's really important.
For sure, I know I do. But like any good deep dive, it leaves me with more questions. So for everyone listening, here's something to think about. We've seen how important turbidity measurement is right now, but what about the future? Like, how will this tech adapt to all the challenges that are coming? Things like climate change, a growing population, and the need for clean water and sustainable resources. It's a lot to think about.
Definitely a lot to think about. As we learn more about water, we'll need to come up with even better ways to, measure it and protect it. The future of turbidity measurement is wide open. There's so much potential there.
And that's what's so cool about science, right? There's always more to learn. Thanks for joining us on this deep dive into turbidity measurement. We'll be back soon with another topic, ready to explore more hidden wonders.
See you next time.